In this video, we are going to draw the Lewis structure of HNO. In other words, that's HNO2. First of all, calculate the total number of valence electrons. Nitrogen, 5 valence electrons. Oxygen, 6 valence electrons. You have 2 of them, so that's going to be a 12, and then you have a hydrogen, which is a +1. This leads to 18 valence electrons in total. Next, I'm going to place my skeleton like this. There will be 2 oxygen atoms around nitrogen, and the hydrogen, I'm going to put it connected to oxygen. So the basic skeleton is going to look like that. Now, why did I lay out my skeleton like that instead of putting it in this format? I have nitrogen, oxygen, 1 oxygen, and hydrogen. Let's try to use all of our 18 valence electrons and see how these 2 Lewis structures turn out. I'm going to place my electrons 1, 2, 3, 4. I need to complete the octet for oxygen. So I'm going to place 2 lone pairs. So I've used 4 electrons. Now 5, 6, 7, 8. I've used 8 electrons from the 18 that's available for me. I'm going to put 9, 10. I know that oxygen always go for 8 electrons. Now I have used a total of 10 electrons from 18, so this is 10, 11, 12, 13, 14, 15, 16. Where can I put my remaining 2 electrons? I would put it on nitrogen, so 17, 18. Oxygen seems to be fine with its 8 electrons, but look at nitrogen. That's 1, 2, 3, 4, 5, 6. Nitrogen is not happy. It's not having its 8 electrons. So what I'm going to do is do a simple rearrangement. I'm going to move a pair of these electrons over here. So I'm taking away those 2 electrons and placing it here, making a double bond in this place. And in this structure, you can see that everyone's happy. Nitrogen completed its octet, oxygen completed its octet, and hydrogen, its duet. Hydrogen cannot have more than 2. And if you look at the formal charges, the formal charges of all these atoms is going to be 0. These are the formal charges. Next, we'll move on to the next structure that I have drawn. So let's use 18 electrons and try to complete this Lewis structure. So we'll put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I used all of my available valence electrons. Seems like oxygen is happy with 8 electrons, but look at nitrogen. That is 1, 2, 3, 4, 5, 6. Only 6 electrons for nitrogen. So we will have to do a small rearrangement. So let's just move this pair of electrons over here and create a double bond. Now it feels like everyone's happy because oxygen have its 8 electrons, nitrogen has its 8, and hydrogen has its 2. But let's see if this is going to be happy as a molecule. If you look into this oxygen atom, you can see that the octet is complete, but this oxygen is bonded with only a single bond. Oxygen is a type of atom that would always go for a double bond whenever possible. When it makes a double bond or 2 single bonds, that is where it's going to have a 0 formal charge. every time oxygen is bonded with a single bond like this, oxygen will end up getting a -1 charge. And every time nitrogen has 4 bonds, it will end up with a +1. So you can think this structure is also correct because -1, +1, the charges cancel off and you at the end reach to this neutral structure. Yes, but we use the formal charges guidelines to determine the best Lewis structure, and whenever possible, we try to settle down to the Lewis structure with the lowest possible formal charges. In that case, it's going to be this. Based on the formal charges, we can say this is the best Lewis structure we can come up, and this is not the correct one.